Hello, my name is Sai Pooja Kosraju, and now I'm explaining the assignment 1 solution in this video. Firstly, here we need two packages. In this particular code, there are sklearn and matplot libraries. Firstly, we are loading diabetes dataset from sklearn by storing features in the diabetes X and labels in diabetes Y. After storing the features and labels in X and Y, we are going to check the dimensions of X and Y. After checking the dimensions, we are going to represent the data in visual format where if we have lots of uh, data, lots of features of data, it will be very clumsy to learn or to visualize. So that we here will reduce the data less than 3D format, that is 2D format, by using principal component analysis. Here is the code that is used in PCA. Firstly, uh, first here from we'll import MATLAB and sklearn. This is how we loaded imported MATLAB and sklearn datasets. After that, from sklearn we'll learn diabetes dataset, and we'll load the diabetes into diabetes X and Y. Whereas here you can see that we we assign that return underscore X and Y is equal to true. That means uh, when the diabetes X and Y, it will return a tuple which is a 2D array, which will return only X and Y features in the form of 2D array as shown here. Here for 442 are the data points in the particular data set, and 10 is the dimension of X and Y. After that, we are decomposing it into 2D array by using this particular function. We are going to use pca.transform of diabetes X. After using this particular function, it will get converted into two-dimensional array. Whereas it's shown here, where the 2 here is the dimension of the data set. After that, we are going to matplot. We are using to plot the graph using matplot library. Here is the code how we use to plot it. Firstly, we are going to assign plots figure size 8:6 ratio, where we are using only 8:6 ratio. That means we are plotting in that particular area, and dots per DPI means dot per inch, whereas it will have 80 dots per each inch. After that, we are going to scatter a 2D array into 0, x2d is to 0, and x2d is to 1, which means uh, 0 and 1 are the columns. After that, we are going to assign X label as principal component 1 and Y label as principal component 2, and the whole title of the plot as figure 1, visual inspection of the dataset. After running the particular code, this is the output that we get, which is visual inspection of dataset. Okay, next, as we seen in the above code, the data is in the numerical format, but it's not in the categorical format. That means there we are performing regression. So in this particular label conversion method, we need to perform classification method, uh, which is usually used in machine learning task to perform regressions. Here, firstly, we'll take an average value of diabetes Y, which is called labels. We'll take an average value of the whole labels, and we'll create another variable which is Y binary for storing binary variables 1 and -1. Firstly, if the if the element which we has taken for performing operation is greater than average of diabetes X, then we'll assign 1. If it is less than the average value, then we'll assign -1. In the graph which we are going to visualize in this format, we'll use plus for positive values and X for negative values for plotting the graph. Oh, here is how we are converting the whole data into +1 and -1 format, which is a binary format. Firstly, we'll import numpy as np. After that, we are going to print the type of the diabetes. That means whether it is numerical or categorical. After that, we are going to separate the classes using diabetes underscore mean. A mean is nothing but an average value of the whole data set. After performing the mean, we are going to use a y binary in piece array. If data set mean, that means I is the value which we are going to store in y binary. If that value is 1 less than greater than 1, then we'll store it as 1. If the data set is less than the mean, then we'll use it as minus 1. Here is how uh, the diabetes y is converted after performing the binary operation. And here we are going to plot the graph for the binary format. Firstly, we are going to take the figure size as 8 to 6. That means it's the boundary of the figure which we are going to plot, and dots per inch are 80. After that, we are going to assign x to the 0, if y binary is equal to 1, we are going to use plus to represent that. That means we are using plus to plot that particular data. If it's equal to minus 1, we are going to use x for plotting that data. Again, here we are labeling x label as principal component 1 and y label as principal component 2, and hold the title as visual inspection of dataset with binary levels. Here is the plot diagram after running this particular code. Now here we are going to generate 1D dataset using the particular code which is mentioned in here. But here we are not using the diabetes dataset. For example, we are going to split data X and data Y into training set and testing set. We are going to take 50 samples in training set and 25 samples in testing set. This is the function which we are going to use for intercept and coefficient, and for using for testing and training X and Y variables. Firstly, we are going to write a function generate data, which we are using a particular function for X and Y. Here it is the function of for loop in range of 1 to 50, 1 to 150, and after each and every step, it's going to increment the value 2. If the for loop becomes true, this particular function will be executed and it will get stored in X. For Y, np dot sign of X plus random normal. We're taking here we are using mean 0 and standard deviation 0.15, and it's going to perform when the particular variable or number is in the length of X. After that, we are going to store X and Y in data, and we are going to return the data. Then here we are going to generate data in print dimensions. Firstly, data X, data Y is equal to, in this step, we are going to generate the data. After that, we are going to print the shape of data X in data Y. Here we are going to import random from here import random. Again, we are going to import train test split from sklearn.model.selection. Here we are going to take seed is equal to 42. That there is no particular rule that we need to take value seed value as 42. As it is said in a particular movie, it's somewhat logic, or it's something that we need to take 42. After that, we are going to generate a random seed in NP. After that, we are going to train and test both the X and Y data sets. Here is how we done it. X train, Y train, and X test, Y test, and we are going to split the test and train sets. The test here we assign the test size to 0.33. In random state, where we need to test or train the set is equal to seed. After that, we are going to check the dimensions of X train, Y train, and X test and Y test as this code is given below. After checking the dimensions, we are going to reshape x and y, x train, both x train and y train. If we get -1, then we are going to ignore the particular dimension, because here we are just only taking 1D diagrams, 1D data sets. So we are going to ignore -1 dimensions. After that, we are going to reshape each and everything, x test, y test, x train and y train, all. After reshaping it, again we are going to check the dimensions and we are going to print it. Here is how it is done. In this particular 50 training sets, there is no particular dimension. That means it may be -1 or +1. After reshaping it, will only get +1 in the training and both the testing sets. Here we are going to perform linear regression. We are going to input linear regression from sklearn.linear model. We are going to take the linear regression function as lr.fit. We are going to fit the linear regression in x train and y train. That means we are going to train the linear regression model. After that, we are assigning coefficient, linear coefficient as coefficient, and linear intercept as intercept. When we run this code, we'll get a particular coefficient and we'll get a particular intercept, which is uh, here y power I is an intercept, and this particular theta into x of I plus theta naught is a coefficient. We'll get particular thing after running this coefficient and intercept one. Then every linear regression model predictions may have or may contain errors. So we are going to print that errors when we perform training or testing on both the datasets. Here is how we get the training error and testing error after performing particular function. Okay, then again we are going to use this model and we are going to plot a graph. This is how we are going to plot a graph. Firstly, we are going to take the figure size in 80:6 ratio, and dots per inch are going to be 100. And X train, Y train, we are going to scatter them, plot the training data, and we are going to label it as training set. After that, we are going to do X train fitted line, and we are going to color the fitted line in red color. After that, we are going to again plot X test and Y test, and we are going to label it as test set. We are going to label X label as capital X and Y label as Y. We are going to get this. Here, a red line represents a fitted line. In blue dots represent training set. Yellow dot represent test set. Here is how we plotted the data. Again, we are going to import a ridge from sklearn.linear.model. Uh, uh, Alpha values are nothing but a particular value which are mentioned in this particular one. Here we go. We are going to mention plot a graph for this particular alpha one, where we are going to take alpha values as 100 and 1000. That means we are only going to plot the alpha value graph when alpha value is 100 and 1000 only. Or we are going to scatter X train, Y train, and we're going to label it as training set, and X test, Y test, and going to label it as X set or test set. Or we are going to color. We are going to plot the color using plot the graph using three colors. Those are red, green, and blue. We are going to iterate the alpha values. When I in range of alphas is nothing but I. That is 100 and 1000. When it's in the value, it's in a range of 110, then we are going to print the alpha value. We are going to perform this particular one or reads. We are going to perform this reads, and we are going to fit in X train and Y train. And also, we are going to print the intercept during the dimension of 0 and coefficient when the dimension value is 0. We are going to print both the test error and train error. After that, we are going to plot the fitted line by using this particular function, and we are going to reshape. We are going to plot when Explain reshape it is in particular -1 and +1 1. After that we are going to plot explain filter line colors of I is nothing but the colors which we are going to take. It's either red, green or blue. Here we are going to label x as x and y as y. uh, After running this code, we'll get printed particular things like alpha is equal to 1. We'll get intercept value and also coefficient value. We'll also get training error and test error when alpha is equal to 1. We'll also get a training value, coefficient, intercept, and all when alpha is equal to 100, as well as alpha is equal to 1000. Here is how it's going to get printed. Previously in the above diagram, above plotted figure, we'll only get one fitted line here. But in this particular uh, plot diagram, we are going to get three fitted lines, which has three different values of alpha. There, one is red color, and green color is 100, and blue color is 1000. And this data, I mean these points are as usual, which is as in same. Blue color data points are training sets, and yellow color points are testing sets. That's all about the code today, which I'm going to explain. Thank you.